Question 1 is a tree diagram question. However, if you read the question carefully, it says that he takes a sock at random and he puts it on before choosing another one. And that means that he doesn't put it back in the drawer, so the probability of choosing a sock the next time changes. So this is what we call a tree diagram without replacement. They're a little bit harder to do than normal tree diagrams. So I've just drawn this tree diagram ready to fill in the probabilities. So we've got 5 blue socks, so I'll make this the blue route, and 6 red socks. So make that the red route. Okay. Probability he chooses a blue then is 5 out of how many socks there are in total. So 5 add 6 is 11. 5 out of 11. So therefore the probability he chooses a red sock is 6 out of 11. Okay. On his second choice, again, he can either choose blue or red. Okay, now if he's chosen a blue sock the first time, that means there's going to be one less blue sock in the drawer, so only 4 now. And there's also going to be one less sock in the drawer altogether, so there's only 10 socks in the drawer altogether. Can you see how the probabilities changed from the first choice to the second choice? Okay, if he chose a blue one the first time, that means there's still going to be 6 red ones, but there is 10 socks altogether. And you should notice that these should add together to make a whole one, just like these do. Okay, if he chose a red sock the first time, that means that there's still 5 blue ones in the drawer, but there are 10 socks in there altogether. And if he chose a red the first time, that means there's one less red in there, so there's only 5 reds, so the probability he chooses another red the next time is again 5/10. Okay. It's sometimes a good idea to fill in the probabilities of all the routes, especially when there's only 4 like this one, and then answer the questions below. I'd recommend that for this one because there's only 4 and then there's 2 questions. So the probability he chooses a blue and a blue, I'm just using a bit of probability notation here, is 5/11 times 4/10. Which is 20, so we just times the numerators, and we times the denominators. 11 times 10 is 110. Okay, the probability he chooses a blue then a red is 5/11 times 6/10. So that's 30 over 110. Okay, the probability he chooses a red then a blue is 6/11 times 5/10, which is again 30 over 110. And then finally, the probability he chooses a red and a red is also 6/11 times 5 over 10. Which again is 30 over 110. Now, question A says, what is the probability that Johnny chooses 2 blue socks? Well, there's only one route that will give us 2 blue socks, and that's this one. We've worked out the probability. That's 20 over 110. Oops. Okay, I'm just going to keep that separate. Okay, question B. What is the probability that Johnny chooses 2 socks of the same colour? Okay, well, choosing a blue and a blue would give him the same colour. But there's another way he could do it. He could, so I'm just going to put or, he could also get a red and a red. And as you've probably seen from this topic already, when we've got and in probability we times, when we've got or we add. Okay, so the probability of getting a blue and a blue is 20 out of 110. Oops. The probability of getting a red and a red is 30 out of 110. So the probability of getting the two of the same colour is 50 out of 110. Remember not to add the denominators.